Welcome to day 6 of Advent of Code 2024. Today I solved part 1 in about 9.5 minutes and 18 minutes for part 2. 4 minutes of this was brute forcing the solution. You'll get to see that live in a bit. So we're going to start off with me solving the puzzles in real time. Let's hit it.
4, 3, 2, 1, start.
I think you should start my phone tomorrow. I will attempt one of them. Maybe. Yeah. Actually, I think
do
to
like
the one right now. Not that I actually knew how to code, but like we stopped coding class, and I've forgotten how to use it. Step over. Wait, I got really bad at it. I got a lot harder. Okay.
Oh, and hex and gates.
Wait, it is just arcade.
Core? That's like fascinating. Or like I think they're like trying to fish for arcade or something.
Ham with 2 M.
Joe Ham or John Ham?
Who's John?
It's probably John.
Wait, there's so many. I think I have 3 that I got this right. Oh. Okay, found this job.
I called you 5 times, bro. Why did you pick up, bro?
Because it started and I was on silence.
Huh?
It started and I put my phone
How the
on.
fuck do you think I don't know where iHouse is, bro?
It says on the door.
Or the ghost house. Okay.
This is so easy.
That's because there's like 4, 3, 4, 6, 9 multiple.
The number of houses aren't on that floor. What's up with that? One would think the number would correspond to what? Incorrect. Chicken.
That's what I was thinking.
Small.
That's all. So, you put John properly.
like you're something pilled.
This feels like a millennial thing.
Wait, this is like a recent thing.
Am I too old for this one? Is this
Pilled?
Oh. I've never heard that.
Oh, I guess. Maybe it's not. But I mean like red pill. I've never heard of red.
I've never heard it as like a with the ED.
No, it's true.
So originally 4chan site.
Oh, that's sick. I'm glad that's not true.
The color of the notional film rather than their actual effects.
Rather than their actual what?
Effects. I'm not sure yet. I'm just going for that. He took the red pill, right?
Alright, so he didn't forget everything.
No.
So, okay, I see. Understand.
Oh, just kidding. Wait, no. Yes, he took the red pill.
Okay.
And then he doesn't forget.
Okay.
I have to make an account before though. This pill. Yes. Oh shit. No. Wanting to be accepting right-wing opinions. What? In alignment with something.
I think that's kind of whack.
The only one I truly believe is what does that say about me?
I don't think that is valid.
Maybe
Oh, I was gonna say like, it's like Beatles. Yeah. That was just like. Yeah, I wouldn't use makeup, and I wouldn't use makeup, and I wouldn't use pillow. And I sometimes use four. I think that's reasonable. I mean, there's yeah. Probably sleep before like 4 a.m.
or I won't and I'll be miserable. Wait, that is super pretty yesterday.
I also did this sleep at like 3 something.
Oh wait, if you just leave it for I did this.
Wait, no, but like, no, like I went to, I like laid down
Sleep,
at like 1 something. And then I was like not falling asleep for some reason. I don't know why. Oh, crap. It's okay. I'm gonna push through it.
Ten to five.
Oh. I remember this game here. Jersey W.
I think I the latter two.
Yeah. Yeah, I feel like that's
Okay,
that's
the last college reunion.
I believe none of them are done yet, right? Yikes.
I think you should start.
I'm gonna do one day.
You got a lot.
100B.
Or a strings. I don't know how I feel about strings. I usually try to get like the spare first, just because I have a ego.
Oh, I just pick what I can get. Oh no.
They go to jail, right? Okay, they have. As long as your mind sounds cute. No big deal.
Oh, I remember
Yeah. March of the Witch Hunter. I don't know what happens in that. For good?
Oh.
Oh.
I'm not gonna tell you that actually. That's my product.
Maybe you're not that bad. I feel like today is not when I should attempt to do this. I think I need to attempt to fix this. I think it's so sad. So I do day one. Lie to me.
I could be unintentionally.
Wait, I haven't unpacked the string.
It's really cute.
Right, so the U has to go.
And then it's probably the E after that. I think it ends in QUD. There's something before it. Like SQD.
Like ESG, like
Yeah.
S.
Oh, yeah.
And go back for an S.
Oh, there's so many letters.
No, I'm waiting 4 minutes for my thing to finish running.
4 minutes?
Yes, because I have a brute force solution.
Wait, I thought we've done.
I'm not gonna get this thing. I'm in trouble last one. In the reprocessing. Oh. Yeah, so it's not as. It's urgent.
Just ignore it.
I'm literally at this guy.
I'm not done yet.
Oh, okay.
There's 20 seconds left.
How do you know how long it takes? Oh, you have like a
TQDM.
TQDM. Very nice. He's using sophisticated tools.
That was me.
Okay, that was so bad. Okay, so for part 1, we are given a guard in a grid with obstacles. So the guard is denoted by an upwards caret, and they are going to walk forward until they hit an obstacle, and then whenever they hit an obstacle, they're going to turn right. So this guard is going to walk forward until they hit that obstacle up there. Once they hit that obstacle, they're going to turn right and then keep walking forward over here, and they're going to turn right again, walk down, hit this one, turn right again, and then just keep going. Eventually, the guard is going to hit the edge of the grid, and that's when we stop. So we have to simulate this, and at the end, count the number of unique places that the guard has visited. To do this, we parse the input first to determine where the guard is. It's given that they're always going to be facing up, so we just scan the grid for an upwards caret, and that's the starting location of the guard. It's stored in the coordinates I, J, and then we need to simulate the guard walking around. So we first initialize a set of locations that the guard has been. It's going to be a set of tuples, which are x coordinate, or like row and column. So at the end, we can count how many places the guard has been to. So while true, we're going to keep iterating, and eventually we're going to break when the guard exits the grid. We are going to add the current location of the guard to the scene list, and then we're going to compute the next location. And that's based on the current direction that the guard is facing. So dir is either 0, 1, 2, or 3, and it indexes into this list telling us what direction the guard is facing. We compute the next place they're going to go by adding that direction vector onto our current location. If the next location is outside of the grid, then we're done, and we can break out of this loop. Otherwise, if they hit an obstacle, then we turn right, and that's done by increasing the direction by 1, basically just going from 0 to 1, 1 to 2, 2 to 3, and 3 loops back to 0 because we mod this by 4. Otherwise, if the guard does not hit an obstacle, then they simply move to their next location. At the end, we print the total number of places that the guard has seen, and that's our answer for part 1. For part 2, we need to find the number of locations where we can insert an obstacle to make the guard go in loops forever. So basically so that they don't exit the grid. How we do this is with brute force. So we have the same code as part 1. We're going to run the exact same code to get a set of locations that the guard visits. So basically just to compute their path, because we have to insert an obstacle in their path. So that's stored in the set called OG scene. And then for every single location inside OG scene, so every single location along the path, we try inserting an obstacle there. That's the coordinates OI, OJ. If this function returns true, I'm going to explain it in a bit. That means the guard will go into a loop if we insert an obstacle here, and so we add 1 to our answer. So over here, there's an implicit typecasting from Boolean to integer. So how this works is this function takes in the location of the place to insert the obstacle and returns true if the guard will go into a loop, and false otherwise. First, we have to insert the obstacle in a new location. So if there's already an obstacle here, then we obviously can't insert it, so we return false. Otherwise, we modify the grid temporarily to insert an obstacle at this space, and then we're going to basically simulate to see if the guard's going to go into a loop. To do that, we maintain a scene set just like we did in part 1, except this time it tracks not only the positions that the guard has been in, but also the direction that the guard was in when they were in that position, because that uniquely determines the state of the guard. So if they're in the same location but they're facing different directions, that counts as a different state. And that's what we do up here. For every iteration of this loop, we check if the guard has been in this exact same state earlier. If so, then we're gonna return the grid to its original position by removing the obstacle and then returning true, saying yes, the guard has been in a state that we've already seen them in, meaning they're going to loop forever. Otherwise, we continue on and we add the current state to the set of seen states. And then we do the same thing that we did in part 1, basically check if the next position is outside of the grid. If so, then the guard will exit, and this obstacle is not a viable location to put it to make the guard loop. And then we make the guard turn right and go forward depending if the next location is within the grid and has an obstacle or not. So, fun fact, my first implementation actually checked all of the locations in the grid for potential places to put obstacles, not just the places that the guard would go on in their path. So that's a big optimization because the answer to part 1 is about 1,500, whereas if you were to search the entire grid, that would be 130 squared, which would be more like 10,000 or like 17,000, which is considerably more. So my original brute force ran about 4 minutes. This new optimized solution runs in about 17 seconds. And that's all for day 6 of Advent of Code 2024. If you want to see my code, it'll be linked to in the description. And if you have any questions or comments, feel free to leave them down below. Thanks for watching, and I'll see you tomorrow for day 7.